Hey all, this is Altbeer. I know I'm a little past our normal stream time. This has been a unique week for me because I got family in town preparing to watch the eclipse. So I had to adjust the schedule a little bit. This will be a shorter than normal stream, but I did want to go over some major progress that has been made this week on the badge. So this that I'm showing on the screen, this is the schematic that I came up with for the Cowboys versus Dinosaur badge. So what we have here is the on the upper left-hand corner, we have the ESP32 Wemo Slowin 32. This is the dev board that we're going to use on the badge to power it up, and it has all the different connections for the things that we're going to run on it. Down here, what we have is the power section where I wanted to be able to switch the battery. So the battery will have its positive lead run through this switch, which will then go into the dev board. That way, when it's switched off, it's like you've disconnected that cable. So that was an important feature. Then over here we have all the LEDs. We're talking about 6 NeoPixels and 9 traditional 2-pin LEDs. They all say blue right now just because I haven't decided what color these are going to be. They probably won't be blue. And these, of course, can be any color we program. So I've laid out this circuit, and then I'll walk through it because I know a lot of people that watch this are new to circuit design and they may not understand what a lot of this means. So yeah, we'll take a walk through it. But I wanted to test it, and so I went ahead and built a dev board to test it out. So this is my little dev board that I built, and I'll walk through what's on here, how I wired it up. But obviously I can't test everything in this little small form factor. So we'll go through what it is I am actually testing for. So here is the schematic again with highlights. Basically, on the dev board itself, the things that are connected on this little proto board here are the 3-volt rail and the ground rail, this GPIO pin 14, GPIO pin 17. 17 is what's going to drive the data line for this first NeoPixel, the only one that is going to be on this little test board. And then down here you'll see 14 is driving this other traditional LED and go underground. So if you think about the circuit design, because we're dealing with basically a circuit, a whole system of circuits on this, it's best to think about it in smaller abstracts, right? So let's take this traditional LED as an example. We know that it's going to have positive voltage coming in one side, and then the LED will light if that happens. It has a resistor to like rate limit the current throughput, and then it goes to ground. So if you were to hook up a battery plus and minus to this, that would be a working circuit and that LED would light. But we don't have just a battery. What we have is this GPIO pin 14. What that allows us to do is to, with programming, turn it on and off or high or low. And basically it either sends voltage out or it doesn't. When it sends it out, this lights up. When it doesn't, this goes off. Now, part of my testing in code, which we'll get to in a minute, is I wanted to do what's called PWM testing, and that's the pulse width modulation. So instead of just turning it on and off, we're going to mimic the functionality of an analog pin where it will ramp on and ramp off. But this is a digital pin, so in order to get that same functionality, we pulse it on, and the pulses increase until they're pulsing all the time and it's fully on, and then the pulses will be lessened until it's dim because it's only pulsing once every so often. So, and there's a frequency, and when we get into the code I can show that, but that was part of the test. But as far as circuit, this is a pretty simple circuit here. We can look at this other circuit. This is a little more complex because we have the 3 volt and the ground make one circuit that will actually provide power to this. But this inside of here is its own little circuit board that is looking for power to come in here. And more than just power, it wants a signal, a specified signal to come in here, and then that will exit through ground as well. So this is how we can signal it to tell it to pass data over this line and say, you need to be red, or you need to be red and blue, or red and green, or whatever. It's doing that with reading the signal in. So I want to test that functionality. And between the battery, the one LED, and the NeoPixel LED, that's all this little dev board does. So let's take a look at the dev board. So it's all put together right now for ease of my use. I have the switch here to switch the circuit on with the battery, and so you can see it's running through some code. I'm even blinking the onboard LED as part of my code testing because that didn't require any external connectivity. But you can see the single LED is kind of fading on and off as the pulse width modulation turns it on and off. It's kind of hard to see in this light. Let me see if I can. Is that better with just one light? That's a little better. And then the NeoPixel is kind of cycling through colors. So it'll like blink colors on and off, and then it'll fade colors on and off. So with that, let's actually take these rubber bands off of here and move some stuff out of the way. And we will show you what we got here. And I'm going to unplug the battery to do this. So what I got is the switch is where I started. So I know I wanted a switch in here to turn it on and off. So the battery, what I have, this is the positive leg of the battery is coming into the topmost pin on this switch. And then the negative leg of the battery connector is coming into this little thing. And I guess I should explain this little green board first. So many of you have probably worked with these guys, breadboards. And the way breadboards work is all of the 5 connections in this row are all connected. They're soldered together to where if you plug something in on one end and plug something in on the other end, it's as if they're soldered together. And each of these little rows works like that. Same thing for these rows here. And then we have our positive and negative rails. And in this case, all of these are connected together and all of these are connected together. So it makes it easy to plug things in and out. Well, this green board is one that a lot of people make these, but they're called like perma proto boards. And this is one that I made myself a few years ago, and I still have a bunch laying around. And it works in the same concept. So if we look at the back, it's just like the through holes, right? But inside of here, a bunch of these are connected. So we have like all 5 of these are all soldered together. They have a trace connecting them. These 2 have a trace. These 2 have a trace. So I thought it was more convenient to break it up into smaller sections instead of just 5 and 5. We can have 2 and 2, and then I still have the positive and negative rails, which are wired up to a positive and negative battery connector here, which we're going to use for a different purpose than the battery on our walkthrough. So yeah, it's just a little board that I use to solder things on. Works the same as a solderless breadboard, but it allows me to do testing in a more semi-permanent way. So with that, we have these 2 grounds you can see are connected on that same ground pin. So this is the ground pin going into this guy is connected to this ground pin. So that means when I hook the battery up to this black wire, it traverses all the way into this black wire, which goes into the dev board. But the positive wire doesn't. The positive wire terminates on this battery symbol. And I think, yeah, I misspoke before. This is going into the middle pin here. and then the far up pin is the one that goes here. Now what this means is when the switch is in the down connection, it is, let me see if I got a pointer better than my big fingers. The switch has 3 pins, which means it has 3 positions. So with the switch on this down position, it's connecting these 2, which there's nothing on here. So this is our off state. When the switch is in the top direction, it's connecting these 2. So that would be our on state, because that's going to connect this red wire from the battery all the way to the red wire to here. And so this is a very simple switch layout. But going back to the schematic, to help people that are trying to understand schematics, this is exactly what we built on this dev board. So we have the battery connector, which is actually what's going to connect this VBAT and GBAT signal. And then we have the battery itself, and it's wired the positive through the switch. So negative goes to this, and positive goes to this, and that would go negative and positive here. So that's what we did to make that happen. I say we, that's what I did when I built this thing. So now let's look at another piece of this. I'm going to pop this guy off. I did use female headers, that way I could reuse this dev board on something else later if I want. But what we have here, you'll see, is 2 different wires. This black wire is where the ground pin on this guy would be. So this is taking ground and it's wiring it up to this negative terminal, which means the negative rails on both these sides here are actually connected to ground on the dev board. And then I did the same thing with positive. It's connected here, which is the 3-volt positive line. And that positive, I then wire into the positive terminal here, which is the positive rails on both of these. So the power that I am taking for these components is not coming directly from the battery, but instead it's coming from the dev board, which is the same way it will be on the badge. And then if we look at that simple circuit that we talked about for the LED, you can see there's pin 14, there's a resistor, there's my LED, and it goes to ground. And that's the whole circuit right there. Now I did put female headers in there to make it to where I can pull out the LED and test different ones, but that is the same circuit that we looked at. And then with this one, it's a little more complicated, but not much. We have that pin 17, he has a resistor. That 17 line from the resistor is coming into this first position here. This is the data in line on this NeoPixel. And then the 2 middle pins are the positive and the negative. And so you can see they're wired across this way, because I wanted, it would have been simpler if I just soldered the LED in, but once again I wanted to be able to pull this out and test different LEDs. So we have it goes the data, then the positive line, then the negative line. Now you might see this little guy. What is that? That is a capacitor, and he's connected between the positive and negative. So if I go back to my schematic, we can see, I guess I didn't highlight this guy in yellow like the rest, but that's C10. So this is a capacitor, and he's connected along the positive line and along the negative line. And so that is basically just to regulate the line. It makes it to where as that LED, because it pulls a lot of power, then a little power, then a lot of power, then a little power, this kind of smooths that out so that other LEDs don't have issues on that same power rail. So all of that is wired in, and it's working. So that's the basics of how to build this dev board. And I might write up something on this, on how to do this on a regular traditional solderless breadboard, because I think it's a good little test of how to work with circuits and how to understand circuits. So if we plug this guy back in and we turn him on, we can see we got LEDs. So now let's look at the code that is driving this. because this will be the same way that we write code for the badge. Obviously, this is much simpler code, but it will be written in the same style. So let's come over here. So the first thing that we have to do for code for this guy is we're going to include the libraries we need. So we need Arduino library because we're writing the code in Arduino, and we need a NeoPixel library to use that NeoPixel LED. The next thing I do is I define the pins that I'm going to use. So the first one is our built-in LED. And so let's go back to the schematic and come over here, zoom in a little bit so that we can see it. And what you'll see here is that built-in LED is associated with GPIO 22. And that's what we're assigning it, is port 22. Now, I'm calling LED 1 pin 14. And on here, if we remember, we have pin 14 is the GPIO 14. That's what is going to drive my D1 or LED 1 that I'm using in the test. And then we have a NeoPixel pin is pin 17. And once again here, we have the pin 17 is what's driving this data line on him. Now we have a couple other things that we have to define. These are constants that are needed for the PWM function, that pulse width modulation that we want to do. So we have to set a frequency, and we have to set a resolution in bits of how we want to deal with it. And then we have to set an LED channel. So there are certain channels on the ESP that are used for PWM, and you have to assign a name to that channel to be able to use that. So that's what I'm doing, is I'm assigning this name, LED1 PWM, to channel 1, and that'll become more clear when we get to that section. So the other thing that we have to define is the NeoPixel. So this is part of that Adafruit NeoPixel library, and I'm going to call it Neo1. And what it's going to ask for is how many NeoPixels are in this string. Well, I had 2 here. It really should just be 1 because I only put 1 on there. Originally I was going to build 2, but the code works with that little discrepancy. And then I tell it the pin for the data line for that string of NeoPixels, and that corresponds to the pin we defined up here. Then we give it the type. There are several types of NeoPixels. You have your red, green, blue. You have blue, green, red. You have the one that has white in it. I forget whether it's red, green, blue, white, but you get the point. There's different NeoPixels, and you have to tell it which one you're working with. And then you tell it the frequency to work at, which this one is 800 kilohertz. And then down here I just have a little debug thing to turn off and on the debug messages. And I also have a delay timer on my main loop that I like to put these things up front so it's easy to make changes without having to dig into the meat of the code to change things that you might change often during testing. I have a little LED off script that all it does is turns off the built-in LED, it turns off the PWM LED, and it turns off the NeoPixel. Now here is our setup. This is where we're going to run this code once to set things up. And the first thing I do is I throw a delay right at the beginning. And what this delay allows for, it's not a very long delay, but if I'm like installing this code and then running a serial monitor, I want to be able to catch the beginning of this in the serial monitor. So this delay is more for me, the human, to start the serial monitor before it hits this point. We give it our baud rate basically for the serial connection. And then this is one of those print messages, right? And this is that little debug thing that I said at the beginning. Well, if this was 0, you would never see this, but I'm going to print to serial a lot of stuff based on my debug configuration. And here's the PWM setup. So this is where we're going to do the setup for the PWM, where we give it that channel that we defined. We give it the frequency and the resolution. Those were the constants that we defined. We're going to attach that to a pin. This is our LED1 pin is going to use this channel for PWM. And that's basically how you set up a PWM pin in the ESP. We have for our built-in LED, this is just going to be a normal output, which means it's going to be on-off. We're not going to try to pulse that one. But we have to define it as an output pin. Then we have our NeoPixel setup. Begin is just in the Adafruit library that we use for this that sets up things in that library to start using the NeoPixels. And then we can set the brightness. Because I'm not actually working with a badge, I have this LED is exposed to my eyeball. I cut that down to about half of its normal brightness so I don't go blind. And then I have another debug saying we're done setting up. Now we have our main loop. Once again, our little debug message. And then what I like to do is iterate over a byte worth of bits. So basically, I'm going to loop through 0 to 255 and then do it over and over again. And the reason for this is I break that into quads of things that it does. So it'll do 4 different things and then start over. And so this is just a little for loop, and it sets up something that's POS, it's our position, is equal to what I is, but that's just for now because I may change that in these groups. So now I'm going to run my first group, and that's where if it's less than 64, that's 1/4 of the grouping. What I'm going to do is deal with the built-in LED by keeping it high for a portion of that time and then low for the rest of the time. So this is the on, this is the off. Now I'm also going to deal with the PWM pin. So this is going to say I'm going to write to this channel and I'm going to give it an integer which is my position times 4, because we want this to be from 0 to 255, and I already determined that this section is only going to run up to 64. And so that will start off, and it slowly gets it brighter to full on. Then we have our NeoPixel. Basically, we're going to, based on the position number, we're either going to flash the blue or green or red, and that's it. And then there's another group that'll be off. So now we're in our second grouping. It works the same way, only this time I'm subtracting 64 from our POS. We have our built-in LED here. We have our PWM pin, only this time we're starting on and we're slowly getting dimmer. And this is where I have my 255 minus that. So this will start on and slowly go down. And then I have my NeoPixel here. In this case, I'm going to start with red on and slowly go to red 0, and also green 0 and slowly go to green on, using that POS number. Group 3 works similar. Once again, built-ins just flashing. This is going off to on again. This is now going to go green from on to off and blue from off to on. Fourth group, same thing. NeoPixel is now dealing with blue and red. Now at the very end of this, if I'm debugging this, I have a lot of print lines where I can show what the iteration number is, what the position number is, position times 4, because I use that a lot. And then I have my delay. This is where it's going to pause to actually show you that LED state. So imagine it's going to go through this whole thing and it's only going to set one thing and then pause. And then it'll go through, set the other thing, and then pause. And then at the very end of this loop, it's going to turn all of the LEDs off, and I'll do a main loop end, and then it's going to jump back to the top of the main loop and do it again because it's a main loop. So this is kind of how I do this code. And you can see it's not a lot of lines of code. A lot of it is comments and debug code. But it's a quick, easy way to test your circuit by doing different things like this, because I'm not just blinking an LED, I'm actually pulsing it. I'm not just doing colors on a NeoPixel, I'm fading colors and blinking colors. And so I'm testing all the different things available to me with the hardware that I put together here. And so yeah, this is code that we'll use similar pieces of this when we write the actual badge code to do all the stuff. But yeah, I just wanted to quickly walk through that. And I think that's about it for tonight. This was going to be a quick one because, like I said, dealing with the family this week, but next week we'll have a lot more updates. I hope to have updates on the Blue Team Village badge, the camera badge, because we do have prototype PCBs on order for that. And with good luck, we might have them in time for next Thursday's stream. So I don't want to jinx myself, but let's just say that would be right on the cusp of the earliest they might arrive. So, but if that's the case, we'll show those off next week. In the meantime, I think that's it. So thank you for attending, and yeah, to the badge team members that we skipped our badge meeting tonight, reach out to me if you have any questions on how to build this circuit. If you need any of the parts to do that, we can hook you up with that. But yeah, we're going to do more tests like this as we test out more things. So this was just the first of many tests until we get prototype PCBs in. And hopefully for those that needed the help reading circuits, you learned a little bit on how to read the schematic and how to understand what it's doing at a physical level as well. All right. Well, this is Altbier signing off, and we'll talk to you all next week. Thanks.